Now let's look how to rewrite a function as a series. So we have this function x times e to the x. Well, if you guys remember from writing out many Taylor polynomials, the Taylor of e to the x is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, and that goes on till x to the n over n factorial. Well, then what we can do with that is say that x times e to the x is equal to, well, x times quantity, this Taylor, because we can write e to the x as this Taylor polynomial because it's an approximation of it. So let's write that out. To the fourth over 4 factorial. It's going to keep on going up until infinity. Well, now we can just multiply each of these terms by x, and we get that x times e to the x is equal to 1 times x, that's x times x is x squared, plus x squared times x is x cubed over 2 factorial, and you get the pattern. You're just multiplying each one by x, so you're raising the power. And that's going to keep on going. So, well, that's the expanded polynomial of x times e to the x, and now let's just write that down with our summation notation as a series. Well, that's just going to be, let's start it from, well, we have an x there, so we can start it from n equals 1 and go out to infinity of, well, we're just increasing the powers by 1 and starting with 1, so x to the n, and we're dividing by these factorials. The factorials are increasing by 1, and let's see, we have 4, 3, 2, so this is going to be divided by 1 factorial, which is just 1. And remember, 0 factorial is not 0. 0 factorial is 1, so we can do that. So we're just going to be dividing by, if we're starting by 0, we'd need n minus 1 factorial. And that's how you can write x times e to the x as a series.